Hey, scalar or not product. Eh, kasa never anymore. So today we are going to do scalar or dot product. Math background. Which color do you like? White or yellow? Or this is black and it is white, right? Let's see. Okay. Hmm. If I use the thing, let me use the black now. Let me use this thing. Let me use the black now. What's that? Alright. Ah, now when we talk about scalar or dot product, this is what we are talking about. It's concept. So if we have um, two vectors B A B, right? Another vector, let's say this vector A. We have vector B as ED, right? A dot B. More often, we like to use the position vector. Position vector A dot position vector B equal to A B dot. I don't want to use. Let me use the capital L. You know me with some of the logarithmic initials here. It is vector A B. You get it? This means A times C plus B times D, as it has been explained in the book. Yeah, and dot product in terms of components and in terms of Cartesian form, the ing form. Are you okay? So you take the top, down, multiply the top, add them, multiply the down, add them. Right. That's the whole idea. Now, if there's something here I want to show you, it says that the scalar or dot product, the term is scalar product or dot product, right? The scalar or dot product of this, where the scalar or dot product of two non-zero vectors AB is defined as A dot B equals the magnitude of A, magnitude of B equals theta. So it means whenever they say dot two vectors, where uh, theta is the angle between them, this is the definition. Are we okay? Let's see as a love emoji we have. Theta is the angle between right. Theta is the angle between the two vectors. Are we okay? Very good. Now, this is the diagram. They are either diverging. So this vector A and vector B. And the angle lies in between them. Or so diverge or converge. Right? Converge means they are coming to the same point. So this vector B and this vector A. Are you okay? Are you okay? Hey, what's in the car? Hello. Come. Can you hear me? Okay. Is it better now? Now, the American in this is what I'm saying. So now, special cases. It's too big one. Now, the special cases. If two vectors mm, are parallel, then what happens? If they are parallel, it means that A dot B is going to be A and the magnitude B cos what? Zero. Because if two lines are parallel, there's no angle between them. An angle is created when two lines intersect. In this case, because there's no intersect between them, and no angle means theta is zero. And now when you simplify this one, it comes cos zero is one. One. So A dot B cos the product of the magnitudes. And what cos zero is what? One. Okay. Now, if so case two, if the two vectors are perpendicular, perpendicular, what happens? In instance, this we have one vector here, we have another vector. Right? Because they all intersect as 90. And they should be diverging or converging any of them. So this vector A, this vector B. Now we know that dot product A dot B is equal to A cos what? 90. We know that cos 90 is zero. So A dot B cos 90 is zero. If here is zero, everything will be zero. So that's it. So whenever they want you to test for a certain property, right? Test if they are perpendicular or they are what? Parallel. They are a special property. You can use these approaches. Whenever you find a dot product for one, I say one or something else. For the parallel, the dot product should be equal to the product of the magnitude. Okay, so let's go from the You can screenshot this one. So this all of these they are examples. I'm sure you can do them. So, but we can do them. Let's use calculator to do it and see. So let's use calculator. Let's solve this one. You know how to solve dot product on calculator. Try to increasing the pop-up display. Okay, let me continue. So now you press mode. Select 8 for vector. Then select 1 for vector. Now you have 3 and 2. The 3 is for three-dimensional vectors, right? That one is higher level mathematics when you're going to the university. And the 2 is the Cartesian plane, the x and y. Mind you, this one you can use your head to solve. 2 times 3 is 6 plus 1 minus 2. You can use your head to solve, you get 4. But I want you to also explore the feature on calculator. So this becomes vector. The first one, so you press 2, you press equal to 1, you press equal to. Are you there? Very well. Now, second one, you press uh, uh, show when you shift. The vector is at 5. 5 for vector. Then select 2 data. Because you're going to input another data. Then select vector B, the second one. Then select 2 for the order of the vector. 2 times 3, -2. Are we okay? Press AC. Go back to your screen. Now you want to find A dot B. So you press Shift 5 for the vector menu. Select 3 for A. Don't go and press this decimal point. The difference, I'll show you something. Look at Shift vector. See there's a dot here in the menu. So you see that dot is in between and the decimal point is down. So learn how to use decimal point and learn how to use dot product. They are two different things. So whenever you're writing, don't write it like how the book has written it. Put it in the middle. So that you so dot product shift 5, 7 for dot. Then come and enter vector piece. Shift 5 and 4. 4 is for vector. The answer is 4. Just like you have in the book. Mind you, if you have your vectors in the calculator, you can even find a magnitude. Right? You can find magnitude of the vector and everything. Right? If you want to find the magnitude of a vector, maybe you want to find magnitude of vector A. You can even use your mind to do it. Root of 2 square plus 1 square. 2 square is 4 plus 1, 5. 5. But let's I want to write magnitude. I'll come here. Shift 5. No, it should be here. It should be here. Shift. Oh, HYP. No. See on the calculator, they've written HYP. As if it's hypotenuse or something. You press shift and the HYP, it gives you ABS. You press shift and HYP, it gives you ABS. The ABS, I've forgotten the meaning. It's about a distance or something. But what I know is that when you put your vector inside, maybe vector A, and you close the bracket, it gives the magnitude of the vector. Do you understand? Similarly, if you want to find the magnitude of vector B, so you see this one is 2.23. Vector B, this side 3.6. What. Let me see if I can duplicate this calculator. Solve the problem. I have two calculators here. What's the first one? I mean, magnitude of reference. Magnitude of B. Let's look at this one. Magnitude of B. 3 square plus negative 2 square. What will you get with 30, which is same as 3.606? Can you see that? Can you see that? Let's look at the magnitude of vector A. Shift 5. Let's try vector A. 2.236. Manually, I would have done it root of 2 square. Root of 2 square plus 1 with 5, which is same as this answer. So you do understand? Very good. So whenever you want to find dot products with vectors or vector addition, so dot product is very simple. Application of scalar or dot product. We come to learn the application. To find the angle between these vectors, you can use this idea, right? So we said over here that the definition of the dot product. Angle between two vectors. A moment, please. So if you are given two vectors, yes and this, right, and they are diverging, it's an angle here, theta. Vector A dot product B equals to A times magnitude of B cos theta. So if you want to find the angle, just make theta the subject, right? So it's going to be look a Wi-Fi way. My mouse. Right? So if you want to make that, it's going to be what? A vector A dot vector B all over magnitude of vector A and the magnitude of vector B. This is going to cos theta, right? And you want to make that subject. So cos inverse of everything A dot B, right? But A B becomes the angle, the value of the angle between them. Are you okay? Okay. So let's use some couple of examples. Now, this technique is the same as unit, a product of the unit vector. You know that a unit vector, right, is the same as a vector over its magnitude. So if you are finding the angle between A and B, we can say that cos inverse of what? Everything. the A over A magnitude, right, times B over B magnitude. It's just another way of writing it. Oh, I want to delete this thing. And this becomes cos inverse of what? A hat unit vector A times unit vector B. Is it dot? Let me check. It's dot rather. Dot product. Cross product is different from dot product. We have cross product and we have dot product. Split the unit vector. I hope you're okay. Very good. Let's start an examples and deal with them. Now find the angle between two vectors. With 3, 1. Anyways, my plate. What you move the thing for? My friend. That's a good thing. Find the angle between two vectors. So we have this vector. Oh, I do come it away. Oh, something's wrong with the machine. Let's continue. Naturally, you cannot go and answer because it's maybe. Are you solving? So for angles, cos theta. Let me code the formula itself. P dot q. If I say P and Q, so P dot q. Sorry. P P dot q plus P q plus P. Looking for the angle, right? So theta is going to be cos inverse of what? E over P. And we know that P dot Q is going to be 3, 1.0 negative 3. So you multiply the top, you get 0 plus multiply the down, you get negative 3. Negative. Are you okay? Now, P itself root of is 3 square plus 1 square. This one's give you 4 to 2 units. And Q magnitude is 0 square negative 3 square. That gives the root of 3. But theta is cos of what? Negative 3 over 3. Make sure I'm it's half rather. Like everything correct. Just for that is what? Negative 3. P and Q. Okay, I made a P star Q. P times Q. Yeah. So the negative 3 is at the top, and then the bottom is with 4 times 3. This one is cancels. And with 4 is 2, so cos inverse of negative half. Are we okay? So negative half is a negative half. So let's go and calculator. Type cos inverse of negative half. Mode 1. Go back to the compound mode. Cos inverse of negative half. Into exotic. Yeah, my bro, you got time? Okay, you can screenshot. Ooh. Another one. Another one. Right here, they say you find three things. The magnitude, the angle. Okay, do this once. I'm coming. I want to see your response. Bro, are you done? What's the value of AB? Okay, so that one we can do it easily with our calculator. Square root of 4 square square 5. That one, that AC is 30, right? So this is 5, this is 13. Solution to the angle CAB. Now, before you move on, right? This thing is they say AB and AC. So AB is here, AB, right? And this is the direction. Are we okay? Now, because of the AC, no, it's the common point is A. So A will be the common point, right? And the angle automatically will come in between here. So this is finds angle CAB. Angle CAB in terms of angle is going to be what? AB dot AC. And the angle is going to be cos inverse. You get it? Cos inverse will come. Cos inverse of AB dot AC over their magnitude. Are we okay? So we know that AB is 4 3. Dot product with 5 of all over their unit 5 and what's 30, 20 plus 36, rate of 36 over 65. So this gives you 30, 66 over 65. But everything is cos inverse, right? That's the angle, theta. So cos inverse of 56 over 65. 35. So yes, 30.5. Are you okay? Another example. You see the angles are not difficult. Okay, triangular versus is OQR. Now, O, Q, and R. Okay, O is 0, 0. Q is 4, 2, 6 is negative 2. Find QOR. QOR. So the angle we are looking for. Right? So the angles can be diverging or be converging. Now, how do you find QOR? Which angles are related? It is OQ, sorry, QO, right? So QO will dot product with what? OR. Then you divide by the magnitude. Then cos of everything is to the angle theta. Are you okay? Eh? So, like QO and O, me, I'll prefer to use it to diverse. Okay, it will give you the same answer. Let's see. So Q is O minus Q. That gives you 0, 0 minus what 2. It gives negative 4, negative 2. The O minus 6, negative 2 equals 0, 0. If you multiply it, you are getting 0 like now. Yes. Sorry, it becomes, so it becomes 6, 2. 6, negative 2. Oh. So you should find the angle. You found this already. Now let's find the dot product of them. So Q, oh, I want to do this. I'm tired. Yeah. After this one, I'll leave you for tomorrow. So now, cos cos inverse of 0. What are they adjusting? Magnitude square plus 16 is 8.0. So this much 6 uh, 6 plus 4, 4. Okay, so 20 times with 40, that gives you root 8 inverse of 1 over root 8 0. So I got this of this. Oh no, I'm making a mistake here. I'm, let me make sure I'm on the right part. Should be with 8 and not with 8. Not here. 0. It's actually find the distance. Actually two equations. So let's multiply. 2 multiply them. Yeah, go and solve this homework. Let's solve it. We have the distance. So now we know that E yeah, QO dot OR code. Q also needs with 20 times that. Negative the vector out of negative 4, negative but negative 3. Was root of cos theta. The ones at the top, this for 24, so negative 24 plus 4. This gives you negative 20. But yes, let me check this. They had negatives in their own. So where for my negative? The dot product 20 for negative 4. It's because of the distance I did. The QO, I should have done it instead of OQ. Maybe not let us to work. If it doesn't work, we'll learn from it. So negative 20 over 800 is going to put negative 20 cos inverse. So cos inverse of negative 20 800 become the t. What are you getting? 135. Let's get the cut this one. I had the angle as 45. It's because I use a divergent, a conventional. See, in the book they use divergent. So preferably, I prefer always using divergent. This is way better. That way it's going to be okay. No, to give you the same answer, so you try that way. Here was the positive. Yeah. Right here, if I write relative to the x-axis, 35 degrees here, 55, 55. Let's see. So this is that way, the one I'm saying. I put down my head downwards. That's why I'm tired early. So you let's call it a day, okay? Better say in the evening to hit me up so that we continue. 7 p.m.